Be going through Creo 8, and for the old dogs out there like me, this is Pro version 36. But what we'll be covering today broke it down into several different sections: usability, productivity, model-based definition, detailing, additive and subtractive manufacturing, and then also generative design and simulation. So we'll cover those topics today. Let's start off with usability. So some things have changed in Creo. They've actually shaded the datum planes and also the menus that will pop up depending on the feature you're using. You'll have something for options and properties and things like that. You can detach those menus and move them elsewhere on the screen. So I wanted to go through a real quick example. First of all, I'm just going to make a part from scratch here. And I just want to kind of highlight something here. So I'm going to turn on our datum planes. So you can see in Creo 8, the datum planes are shaded. And this actually kind of helps a lot to kind of more highlight the datum plane, especially if it sticks out a little bit beyond the part. So you can see exactly where that plane is and how it intersects with the part. But one of the things I thought was kind of interesting, I'm going to go over here for a second, is that you can color the datum planes. And again, going back to the old days, the datum planes were kind of, in the old days, were yellow and red, and you could only see that when they were on edge, and you could tell that there was a positive side and a negative side. And Creo and Pro has always had a positive and negative side, but you notice they've kind of made them the same color, so it was really not real obvious. But what I'm going to do here in Creo 8 is I can change their colors. So I'll say make the positive side green and the negative side red. So now we look at, now the planes are green, and if I spin them around on the other side, you can see that they're red. So the reason it's getting the positive and negative directions is basically from our coordinate system, right? So positive X is this way, so the plane pointing in that direction is green, and that's really how it kind of works itself out. But where this is kind of useful, a lot of times you kind of lose your bearings if you're working with a symmetrical part and you're spinning it around and working on it. You're kind of wondering, which side am I looking at? Using the different colors like this can kind of help you a little bit to figure out exactly which direction you're looking at your part from. So the other thing that I mentioned as well is that we can kind of detach the menus. So one of the things that I'm going to do here is we have a, this isn't going to be a weld presentation, but we're going to kind of use this weld as an opportunity to show this. So you can see we have our location menu that pops up here, and we have intermediate here. I can take this and just move it over, maybe move that down here. I can maybe take options and move that maybe down in this corner. So now I can kind of have multiple aspects of this particular feature on the screen at the same time. I don't have to click through different menus to access them. So in this particular example, nothing fancy, but we'll say, let's make that really 5 welds, make a change like this. Now, one thing that's interesting about this, let's watch this as I finish the feature. Now we're back here. If I ever go back and say I want to redefine this weld, the menus come back where I put them. And again, it makes it real easy for me to kind of customize the interface of a particular feature, and it will always look like this. If I want to send them back to where they were, there's a little button here. First one just closes it, but this one says reattach it to the menu. So I can just kind of do that. And so now, next time if I go back to this particular feature and say let's redefine, it just pops up the first one, right, for location, but everybody else is still intact. Again, I can move them around later on. So let's go back to our PowerPoint here. So I'll be kind of bouncing back and forth between the PowerPoint and doing little demonstrations. The next thing that they've been added is in the model tree is something called a design tree. And this comes in real useful. A lot of times if you're doing a lot of surfacing and things like that, you can group things together. That's really what its purpose is, so that you can kind of, maybe the way it was modeled isn't exactly the way that we would want to group different things together. Everything that has to do with the seat of this product that I'm designing, I can put all those surfaces under a folder called seat. And it might not have been modeled that way. I might have imported some features and then copied them later on in the model tree, and then done some other merges and trims, and it could be spread out throughout the whole model tree. So this kind of helps organize things and makes it a little bit easier to understand a model, how it's organized. And then also if it's somebody else's model you call up, you can kind of see how things are put together. There's also another thing here that's been added called a snapshot. And basically what it shows you is the untrimmed surface. And you could do this before a couple of revs back where you can make a copy of a surface and then you could say untrim it, right? And that was a couple of picks, and not a lot of people went through that, but now you can just pick on a surface and say, show me the snapshot. And it'll show you that surface in the untrimmed, before it was modified type of fashion. So we'll take a look at that, right here. Let's minimize this guy. And let's take a look at, let's see if we can find our guy here. I'll call him up. So here's the feature that we want to work with. As I mentioned before, it's a new type of tree. So we have, our layer tree, we can turn that on. And again, we can take the layer tree and kind of pull it off if we wanted to, or reattach it. But over here is the design tree. So I'm going to turn that on. So the design tree captures a couple of things out of the box. We can see that it captures quilts, captures bodies, right? There's multiple bodies in this particular product that I'm working on. And then these are the folders that I can create to kind of organize things. So we can kind of see here, I've organized it into like a housing, there's a glass on the front, there's a button on the top, and some other supporting documentation. So ways of me kind of grouping what we would see over here, which might be spread out all in different areas. So for instance, let's kind of expand this out. We can see we have different quilts here. We have the housing stuff here. So I'm going to go in and say, let's take a look at some of these quilts. So one of the things I mentioned, you can say, I'm going to right mouse button and say, show snapshot. So it shows me that particular surface. I can go to this one, say, show me the snapshot here. And we can see it's added, it shows me the second one. And I've kind of made a little map key so I can pick on a surface and just hit the map key and it'll show me those. To turn these off, you just click in the graphics area and they go back away. But we can kind of see those surfaces before they were trimmed. But these are part of the surfacing that would define this outer body. So I'm going to grab these guys. I'm just holding my control button down. I'm going to say, let's drag them under this driving surfaces of the housing. So you can see we've kind of organized it there. And so now they're all organized under one heading, all the surfaces that have to do with the outside of this. We also see over here is that we also have a folder for buttons. So we have the body of the button here, and then we also have a surface. If I click on that, we can kind of see the surface of it here. I'm just going to grab both of these as well and just drag them under the folder that I made for button. So now they're all organized under the button folder. Something else that we can take a look at, a couple of surfaces here. I'm going to take a look. We can kind of see that these little grooves have been made from these surfaces. So I'm going to go over, it's part of the housing. So I'm going to say, let's make a new folder for that. And we'll kind of rename this grooves. And then I'm going to grab this quilt and drag it into there. So now our grooves folder that I made is made up of all of that. And then I can take this and maybe include that with the outer body, because those grooves do sit on top of the outer body. So now they're all kind of organized. You can notice I'm making kind of a little sub-assembly of surfaces here. Again, totally independent of the order in which they were created. Another thing that I can do, let's take a look, just kind of finishing this up. There's a couple other quilts that I haven't messed with yet. We have one here for, the glass, and then also just the cutout for that particular glass. So we could take these, here we have our glass over here, and I'm just going to grab these and drag them down into their surfaces. So now everything's organized. You notice I've taken all the bodies and all the quilts and kind of organized them in a nice kind of model tree in a way that we can kind of get at things. And one of the things we can also look at and kind of make use of this show snapshot, because we're going to kind of see the progression of how this outer part was made. So I'm just going to say show the snapshot of this. The next thing it was done was extend it out here. Then there was another extend. I can see it here. Then we kind of merge those together. So I'm just kind of saying show snapshot at every one of these, and I can kind of play through exactly how this thing was built. Again, I'm just using my little map key here to kind of build our part. And so now we can see the outside surfaces and how it came about. Another thing with this as well is that if I do pick on a particular surface, it cross highlights over here in our tree. You know, not only in the model tree, but obviously in our design tree as well. So we can see that everything kind of is organized together now. So that's the design tree. It's actually a pretty useful tool. I think you'll find it, again, especially if you do a lot of surfacing or if you have a lot of bodies, a lot of multi-body designs. If you're starting to use that more, remember that came out in Creo 7. This is actually going to be a real useful tool for things like that. So going back to our PowerPoint here, the next thing I wanted to talk about is some usability they've added for holes. We can create a sketch and it'll put holes at the vertexes or at the midpoints of that sketch. Also, we can do lightweight representations. People didn't use that real often. It would only work with certain holes, but basically you represent the hole just as a circle on the surface or as a point. So that would make it really lightweight. The reason you do that is maybe if you're using rivets and you have like hundreds or thousands of holes in something, you can reduce that so the regeneration times and things like that would be reduced. And we also have improved some of the thread handling, but let's take a look at this. So let's close this guy out. So here we have a part, and I've created a sketch here, and I've created them right here. So it's a little octagon, and what I want to do is put some holes on him. So I'm just going to right mouse button and say, let's make some holes. So holes get put in a number of different ways, 3 different ways. You can put them on sketch points. So I actually made some sketch points, just kind of randomly pick some points in this sketch, just along on each leg of this octagon. And it's putting holes at each one of those. I could say put the holes at the vertex of our octagon. So we've got our 8 holes here, or I could say at the midpoint. So any straight line at the midpoint of that line, and we can see those there. And I can mix and match them, right? So I can have it at the midpoint and at the vertex. But this allows us to go in and actually kind of create a pattern. We'll just say, let's make this like a through-all hole. But it allows us to make a pattern here. And again, as with all patterns, if I were to go in here and pick an edge on something and say, let's make a chamfer there, now I can come in and say pattern that, and obviously it's going to pattern. So it's a pattern like any other, but it's just based on a sketch for making holes. Going back to our PowerPoint, this is a new capability as well, and it's kind of bleeding in the way I look at it, some existing technology that's been around in Creo forever. A lot of times, if you do an assembly feature, do an assembly cut through multiple parts, the assembly file itself is pretty much empty. There's no geometry in it, just a bunch of pointers to all the parts that are in that assembly. But as soon as you do assembly cuts, any of the parts that are affected by that cut get copied into that assembly file. And so then you got pointers and geometry in those. So the assembly file gets larger. Well, this is one thing that you can use called Inseparable assemblies in Creo 8. And what that allows us to do is basically embed other parts into the main assembly. And this would be good for purchase parts. I buy this hydraulic cylinder and I don't need all the individual components. If I just had one assembly file that had all the parts in it, that's really all I need for my assembly, and then to place it in there. So this is going to allow us to kind of merge parts into an assembly, and they're all held in that assembly file. At that point, you can actually get rid of all the individual part files if you wanted to, because they're no longer needed, right? They're embedded into that assembly. So let's take a look at it as an example of that. Let's see here. Here's our example that we have here. If I take a look at this guy, I'm going to kind of open this pattern a little bit. It's made up of different sub-assemblies, right? Different sections here. And then there's a couple of plugs right, that go on here. And right now they're all individual components. If I look at one of these plugs and open up, it's made up of a lot of individual parts that are inside of this. What I want to do is kind of talk a little bit about this inseparable capability. So I'm going to pick on one of these subassemblies, this one plug right here. I'm going to right mouse button on it, and I'm going to say inseparable assemblies. So we can either embed, that means take apart and embed it into the assembly. We can say make inseparable. So we do that kind of at the assembly level. We'd say take everything that's in this assembly, or subassembly in this case, and merge it into that subassembly file. And then we can also say make separable, which is kind of going the opposite direction. So it's not a one-way trip. So I'm going to say make inseparable. So basically merge all these components that we see highlighted there in green into that subassembly file. So by doing that, it says you can go into advanced, tells you a little bit about what it does. It can affect some of the things that you might have created in that assembly level, because no longer is it going to be an assembly, it'll be a single part basically. So, you know, with everything you do, there's always another impact that it can make, but the description of what potentially could happen is here. But again, if we're just using purchase parts and we're just kind of trying to get them a little bit organized so we only have one file to deal with and it just shows up in the bill of materials as a single file, that's a good thing. So I'm going to say, let's go into advanced and take a look at how it looks at things. So here it has all the files in the assembly. And you notice it's not messing with any of these, but when we do get to our plug, it's starting to embed all these parts into that plug that we have here. And we can see that, and we do have two plugs, so we'll see that happening twice here. So that's what it's doing. And watch the names change over here. You see how their names are listed out here. It's just called, you know, amp plug and things like that. I'm gonna say okay. As soon as I expand it out and look at their individual parts, they have a different icon next to them now that they're embedded. They have the name of the original part and then the assembly they're embedded into after it, right, with the little carrots on either side. So it's letting me know that these parts, you know, not only visibly by the icon, but also by word, by description, name, that is showing me that they're embedded in there. And even from a top level, I could come over here to our main top level assembly, and just under operations, I can also do it from here, and I can say make inseparable. And so in this case, it's gonna, if we take a look, it grabs everything. So everything that's in this model tree is getting embedded into the top level assembly here. So I'll say okay. So now that has all been embedded. And if I were to say like file, back it up, right? Let's do a backup onto my desktop. So with this guy, I'll close him out, and let's say erase that stuff out of memory. Now if I say let's open it up on our desktop, it's just that single assembly file, right there. Take my word for it, if I move all these windows over, it's just a .asm file sitting out there. But if I go and open it up, now we see all the parts are in it. So now we have one nice, neat assembly file, a .asm file, but it's a single file that has all the parts in it. So that's really the advantage of this inseparable capability, is it's just taking things and merging them together, making it a little bit easier for us to work with things like this. Let's go back to our PowerPoint here. A couple of other areas that I want to talk about is in cabling. Some new branch tape and shrink wrap has been added, and then also in sheet metal, multi-flat walls have been added to make it real easy to continue using a definition that you have for a flat wall anywhere else on the part. And then this is really kind of interesting. It's called a geodesic curve. And typically a point between, or yeah, a line between 2 points is a straight line. But what this will do is it'll say on a surface, and it will follow that surface, and then if there's any bosses or holes, it will go around that. So it won't necessarily be a straight line, it will stay on the surface and then go to the second point. So this is some technology we saw in the spark analysis, right? Where we might have electricity traveling along a surface and it has to go around certain things. So this is what it does. It finds the shortest distance between 2 points while avoiding obstacles. So it'd be kind of interesting to see how people use this in various ways, but should be interesting. So let's let's close this guy out. And let's call up let's start with our cabling here. So here's an example of a couple of harnesses that we have here, and we can kind of talk a little bit about some of the new things that have been added. So I'm going to go into cabling, and we'll go working on this first harness, this top one that we have here. And what we want to do here, the two new features that were added, so branch tape. So basically we're going to, before you'd always add tape, it was always along a single set of cables, right? It wouldn't be able to do, you'd have to do a branch tape here, and then it would look kind of bad. So what we do now is we can put tape on in where it branches off, basically. So I'm going to use branch tape. And it's easier to do it when it's in centerline display, but I'm just going to say, let's go add some branch tape right at this intersection. You know, how far along each leg do you want it to go? Again, I can enter in that value and then say, okay. So if we take a look at it here, it's kind of made it the same color. So let's take this guy and redefine him. We'll use a different color spool here. So here we can see it in black. So this is the tape that it made covering up. And again, it's taking that 16 point whatever down here, but I can kind of control the length of that. The next one is similar to that, but a little bit different. So it's over here on this second harness. And in this case, we're going to add this feature called a stiff shrink. And what I think it's doing in the background, it actually kind of puts a little axis on there, and it's kind of using that along capability. And what it does is it forces all the wires that are along that axis to be bunched together. So here they're all kind of bunched together. That's great. But up here, they're starting to spread apart a little bit. And so that stiff shrink wrap will kind of force them to kind of bunch together up until the end of it. So let's put it in. You can kind of see how it works. So I'm going to say, let's add it in again right here. And you can kind of see this is that little axis that I was talking about. So I'm going to say, let's give it a length instead of this, let's say 40 millimeters or something like that. And so now the things will be all bunched together from this point out to this point. If we say okay, we can kind of see that. If we display it as thick, we can see how it's forced these back together so that they would fit inside of this. So that's kind of what the stiff shrink would go. The other thing I was talking about is for sheet metal. So I'm going to go in and say, let's use this definition, and let's also add it maybe right there and there. So you notice I can just keep using the same wall in different locations on the part. And as well, I could pick it down here. You notice that it automatically creates a nice miter cut between everything there. So I'm continually using a predefined wall, just applying it elsewhere on the part. If we come around maybe to this side, I'll kind of do something similar. We'll just say, let's make a flat wall. I'll say along this edge and that edge and this edge. And that's like way too big, so we'll kind of drag it down a little bit. But what we can see is if we look at the corner here, you notice I had moved one of my menus over here, one of my options, so it's visible right down here in the corner. I can start making changes to it. I don't have to go up here and pick miter cuts, but I can go under here. There's different displays. So here's, if it's tangent, we have kind of an open section here. If we wanted to change that to closed, it'll seal it up. And then we could also just say, let's just have it rip, where it's just ripping the material. So again, real easy capabilities here in sheet metal, just making it a lot easier to create flat walls on parts throughout the part. Going back to our PowerPoint here. Another thing that was added is in render mode, we're using KeyShot, right, to do that. There's the ability of it now to use the graphics card, the GPU, to do the processing. And that's what graphics cards do, right? They have hundreds of processes where your laptop, your desktop might only have, 2 or 4 or 8 or something like that. The GPU could have hundreds of processors. That means it goes really fast. And if you do have an NVIDIA card, it can use that graphics card. So there's a couple of config options here. One for advanced rendering mode, and by default it's set to auto. So basically, it will use a graphics card if there is one. Otherwise, it will use the CPU. But you could hard code it in, say, neither GPU option or the CPU option. And then there's denoise, and that's basically when you're using the graphics card, have it render faster, and it makes the whole process go quicker when it's leveraging that. Here's that denoise button. In fact, if you see this and it's not grayed out, that means you got a good graphics card, right? Because it recognizes it, because Automatic is there and it's sniffing around and sees you got a graphics card, and you can turn that on. So let's take a quick look at that. We'll do it maybe with this guy. So I'll turn on rendering. And so here's our part. And here's the denoise button. So if I select that, now it's just going to make it a little bit quicker. It just sharpens up a little bit faster as I'm orienting this part around. But again, it's doing this on the graphics card. If I was showing you my task menu or basically the performance, you would see that the NVIDIA card that I have is working out. It's working right now as I'm zooming in and zooming out. Whereas before it'd be the CPU that would be doing that. So we'll kind of close this out. Let's go back to our PowerPoint. So the next thing we want to talk about is model-based definition and detailing. So one of the things for the GD&T advisor, so that's sort of like a spell checker for putting on a model-based definition, GD&T symbols and things like that. It would tell you if something wasn't correct or you forgot to add a tolerance or something like that. And you could double click on it, it'd give you like a little message down here, and it'd bring you actually to the chapter and verse in the book of, this is why you need this. But so now, it was always, GD&T advisor always worked on individual parts, but now you can work on assemblies as well. So you can constrain parts in the assemblies. And if you need to create some other dimensions or notes or something like that, you can pop out of the GD&T advisor, go into annotations, add the things you need, and go back to GD&T advisor without ever exiting it. So that's kind of the important thing too, is that you can kind of stay in that mode, checking things and still go out and create some other things as well. And there's also some control in there for getting mismatches and things like that. If there's some extra text in there, something that isn't to standard, it can go in there. It'll first of all highlight it for you, but then it can actually, you can click on it and say, okay, update it to the way it should be, and it would remove the unwanted information, as an example. Another thing with model-based definition is they use the word semantic a lot. And semantic just means if I have a symbol or a node or a GD&T and it's pointing to a surface, that surface is a reference. If I could pick on that GD&T, I can just say, show me your references, and it would highlight that surface for me, which is great, right? So there's a relationship between the note that you see and the surface that it's affecting or it's referring to. And in this particular case, you've always in the past, if you use multiple surfaces, you just hold your control button down, pick surface, surface, surface. Well, now you can use rule-based type of things. So surf and bounds, loop surfaces, intent surfaces. So if you need to grab a lot of surfaces, it just makes it a lot quicker to do so. Just gives you that ability to do things like that. And then also in detailing, there's new sketching tool. And so again, we're kind of bleeding in some technology from other applications. In this particular case, it's from Creo layout, but it's using the sketching tool there. And again, this makes it a little bit easier to create drawings. If you've ever sketched in Creo detail, you'll know that it's not fun. So let's take a look at it. So here I've called up a drawing, and we're going to go into sketch. And so you notice the menu has changed, right? So now we have different things that we can sketch, rectangles and circles and ellipses and things like that, like you'd see in any other sketcher. Watch when I go in here, let's kind of zoom in on here. I'll say, let's make a rectangle. You notice it's automatically dimensioning now from, the side and the bottom of our borders, and we could say, let's make our part like this. And I don't know, let's maybe make a line. So I could say, let's create a line here. We go over to here, let's make it like 2 inches. And then we'll kind of click that and we'll go off at an angle we'll say maybe, let's say the ankle is 45. Come on, Bill. But the thing is that we can go in and create this information. As we're creating it, we're getting numbers. We can put in those numbers and then kind of continue on. We'll keep that the same and maybe make this at 45. And then continue on. So it's a lot easier to create two-dimensional geometry should we need to do that in the sketcher with this new kind of interface. And like I said, they're borrowing this from Creo layout. So, you know, it's not anything that was reinvented. And actually it kind of gets rid of another, there's like about 4 or 5 different sketchers throughout the Creo applications. And so that just got rid of one, right? Because now 2 of them are sharing the same one. So that's always a good thing as well. Let's go back to our PowerPoint here. And we'll talk about additive and subtractive manufacturing. So this is kind of interesting, additive manufacturing against this 3D printing. But in the past, you define a volume and you say, okay, fill this with a lattice, you know, some kind of structure. And you could have, you know, lots of different types of cells that would make up this lattice. And you could change the density. You could say along this edge, you need more lattice structure because it needs to be stronger here. Well, one of the things it'll do now is that if you ran an analysis, a structural analysis, whether in Creo Simulate or Creo Simulate Live, and when you create the lattice, you could say, look at this structural analysis I made and make the lattice according to that. So where the areas of high stress is, it would put in more elements or more of these cells. And where there's low areas, it would put in less. So it's actually building according to the results of structural analysis to make sure that there's more of an even distribution of, in my description, of stress, you know, throughout the part. So it's kind of a smart way of what PTC calls simulation-driven lattices. Another thing, and this was in Creo 6, I believe, when they added this build direction. And you could say, and this is for kind of optimizing a part in a 3D printer. And so how do I want to look at it? Do I want to minimize its footprint? Do I want to minimize its height? Do I want to minimize the number of you know, structures that need to support this? So there are different things you could look at, and you could pick any one of those and do it. Also now in Creo 8, you can use all of those. So you can take all those different ones, assign a weighting to those, and it will look at all of them and optimize your part's position in the 3D printer, taking into account all of those things. So it's really kind of a nice, easier way of kind of optimizing you know, the printing of the part. And also, and this would be under the heading of subtractive manufacturing, or what in the old days we just called manufacturing. But in Creo 5, they came out with 3-axis high-speed machining. And so now in Creo 8, it's updated to 5-axis high-speed machining. And then there's also auto deburring, so it looks at all the hard edges on a part and creates a tool path to drive a tool along those. And then additionally, there's also some conversion from 3D milling. It'll be, you know, you have a part fixtured, it'll use 3-axis milling on that part. And if it had some undercuts or it had to use 5-axis, it'll switch to that. So you don't have to refixture, reorient your part. Again, you need a machine that can support that, obviously, but it can switch then to a 5-axis machine to finish up the part if it needs to. So it's kind of a nice little transition to that. So the next thing I want to talk about is generative design and simulation. So first of all, Simulation Live, when it started with fluids, right, and that was like last release, so Creo 7, it was doing it in a transient state. But now the default is a steady state. So as the fluid has reached a steady state going through or around some product, we can take a look at that at the steady state moment. And we can also redefine the probes, right, where they are on the part and what they are sampling. And then in the ANSYS simulation, so ANSYS The merger with ANSYS and Creo was 702, so it wasn't the beginning of Creo 7, but the second release after that. What we can see is that we can starting to add in like mesh control will show up in the model tree, and diagnostics for creating elements and things like that. That type of information is starting to be made available. And then additionally, it automatically will grab the ANSYS license to run that. So we're going to see a lot more things happening in this particular product as it matures, and as PTC puts more and more hooks into the ANSYS capabilities and pulls them out into the interface and into the model trees and design trees and things like that we have in Creo. This next one's pretty interesting. So this is generative design. It's also referred to as GTO for the muscle car guy. That's not a Pontiac, but what it is generative design optimization. And what it will allow us to do is define some areas that we want to have in a part, and then we'll build the rest of the geometry around it. And it'll look at it in certain ways. Is this going to be a cast part? Is it a 3D printed part? Is it a machine part? And it kind of builds it according to those types of needs. So let's take a look at an example of that, because it's actually really kind of neat. So I'm going to call up our assembly here. And so here I have some different bodies out here. So we're going to make use of bodies a lot in generative topology design, but we have some areas here called preserved, right? So you can kind of see these separate bodies, and these definitely need to exist in our part that we're going to be creating. So this part is going to be fastened down here by, in 4 locations, and then there's a couple places here, and they look like they're coaxial, so there might be, an axis or a rod or something going through these, but we need this type of geometry in our part no matter what. And in the past with the generative topology, we'd have to create kind of a box around this. And we'd say, okay, now whittle this box away and, kind of connect up all these areas that I do need together, and then try to remove, a lot of material. And it would kind of go at it with a Dremel tool and just remove things. But in this case now with Creo 8, and if we go over here to generative design, it will allow us to create this geometry, this envelope geometry on its own. It'll create it for us. So one of the things you see in here, there's a lot of icons out here. And this basically runs off of, it's sort of a combination of structural analysis and generative design, because we need this part, but it's going to be fixed in these areas, right? So that's what these icons represent. So we could just go over here and say, we have constraints, and we can pick on these surfaces. That's what was done here. So these were already set up for us in this example. And then down here, there are some loads, right? So there's a load pushing up on it, and there's some loads pushing it over to the left here. So it's going to be kind of a lifting kind of a force on here. So design a part that connects all these together and then kind of distributes the load between them. So what we do is we have our included parts. So we just basically say, let's pick in the geometry that we need. So let's say the included parts that we need in our model tree here. Let's kind of make this a little bit bigger. We're going to say, this guy and this guy. So I'm going to pick all of these that we're looking at, and I'll say, okay. As soon as it has that, it builds the geometry around it. So now it's got geometry all the way around it, and now it'll start removing this material, leaving this. But we also can put in information because these are going to be holes, and probably something needs to go through here. We want to make sure that the material on the outside out here is removed as well. So that would be under the heading of exclude geometry. So there's some other information that we have over here that we've sketched, and this is going to say remove this material. So it's going to do a Boolean on this big blob that it's created here, because we want to make sure that it's a nice clean path down here and then going through those holes so that we can put a bolt through there. So we're basically saying do not kind of remove this material from here. So if I take this guy, we'll go into our exclude, and I'm going to pick these guys as well and say okay. So it kind of does a Boolean subtraction, and we can kind of see it's cut it out in these different areas. It's also cut like a little hole through here. So now we have a nice clean face going right up to here. And then we have this surface that's definitely going to be here, the blue stuff. And then we have a gap between there, and then it comes out the other side. So we're kind of generally picking the areas that we want to have open and the areas we want to keep. And based upon this, it's going to go in there and start to do its study. So we can say, let's add some design criteria. So basically we worked our way down here. We said, preserve geometry, exclude geometry. We had our loads and constraints on there. And we can go into our design criteria now. And when it's done making this part, how much do we want it to weigh, right? So we could say, let's make it like 1.5 kilograms. So we'll add that in there. And then there are different kinds of constraints. And I kind of referred to this earlier of what these constraints could do. But when we're removing material, what do you want to keep in mind? What kind of rules do we want it to follow? So there's different constraints here. So there's a build direction, right? So if that was a 3D printed part, what direction is the build direction? So it kind of organizes things that way. Here's a parting line, right? So if we're creating this as a casting or a forging or plastic part, we'd have a split line, and we'd have draft on that. And then here's a linear extrude. That is if it's a machined part. What I'm going to do is I'm going to say, let's do planar symmetry. So we want this to be a symmetrical part. As you can tell, it's kind of laid out that way. So we're going to say, let's use the right plane. So that's right down the middle here. So whatever you do on one side of the plane, do the exact same thing on the other. So we end up with a symmetrical part. Another thing I could do is, and I have to say, what is this material made of? If I'm going to say it weighs 1.5 kilograms, I have to say what the material is. So here I'm going to say, let's just make an aluminum part here. And we'll say, okay. So now we've got really everything defined, right? We went through our preserved, our excluded material, put in our loads and constraints. We said, build it according to this. And, the study design is, how it's the fidelity thing, right? What element size do we want? Because it's going to tessellate this model, right? And then start removing material. And then how many iterations do you want it to go through to find the result? But we're going to say, let's optimize this guy right now. And so now it's going to start building. And with Creo, it's always had the little spinning wheel down here, but now it has something over here telling you it's working on, and even up here in the upper right-hand corner, it's telling you it's optimized. So you're going to definitely know when it's finished doing what it's doing, but you can actually see it building the geometry here. As it's reducing it, the total mass down to 1.5 kilograms. Roughly you can see it's 1.533 kilograms, says optimization is finished. And we can see the component here. We could even go in here into display, and we can say, let's look at, we can see the von Mises stress here. So obviously the stress can be high here where it's being held in place, but we could also take a look at it from the standpoint of displacement. And again, the back end is going to move. We could say, let's animate that a little bit. And we'll kind of speed it up a little bit here. Let's say play that. So we can kind of see it moving. So again, it's sort of a combination of structural analysis and not structural analysis, but just, kind of geometry creation in order to get us what we want here. So this gives us our design. And again, we didn't really say build it for it to be a casting or anything like that. So it's made this kind of webbing in here. So this is kind of the part that it's come up with. And we could come back over here and we could go make some other changes to it. We've got it down to the correct weight that we wanted it to be in. And that's pretty much set up. But let's go over to our design tree over here. Let's say, let's redesign this and let's go in and add in, here's something called minimum creases. So what it's doing is any sharp edges or sharper type edges, we're going to say, let's change this and let's use maybe like 6 millimeters. And we'll say, okay. We can say now optimize it according to that. So what that's going to do is kind of round it off a little bit more. So it's going to have to generate some new geometry, but it's also going to get rid of that little webbing, those little holes that we had back here, because those are kind of sharper, more curvature. So it's going to make this a little bit more organic in shape. It's still going to weigh that 1.5 kilograms that we're asking for, but it's going to look a little bit nicer now. So here it's down to the 1.56 and still optimizing a little bit. And so there's our new part. So we can say generate this design. And in this case, we're going to say, so a lot of these, there's other packages out there in the world that do this type of thing. But what they do is they give you tessellated geometry, because that's what it's doing, right? It puts a lot of elements on here and then starts removing them. And you end up with a bunch of little triangle surfaces, and if you have to work with that, it's a real pain because it's not a real surface. So what we do that's different is we use a freestyle feature. We can read in this tessellated information and make it a surfaced model. So that's what I'm going to do here, is say, let's generate that surfaced model. And now I'll have real surfaces that I can work with, not a bunch of little triangular shape entities. So this is going about putting that freestyle feature on our part. And when we're finished, we're going to have a fully surfaced part that, that we can start using. So this is kind of the future of design, where we put in the criteria that we want, and then we let the software decide what it looks like, and then we can tweak it. We can keep going back and redefine it. It's Creo, right? So we can always go back and make changes to things, change the material, change different loads, things like that. One of the things too is that this does not stop you from working while this is generating its design. You can still go and do other Creo stuff. I didn't do that. I probably should have went in and started doing something else, but it doesn't lock the CPU. But here we can see our new part. And so this is it. This is what it came up with. Again, you can kind of see the original geometry. It is keeping that, but then it's kind of building in a network to kind of support that supports the loads that we had previously defined and moving forward. So this is generative design.